thank you for joining this talk. I'm very happy to present here at PyData. And yeah, let's start. So I hope this is going to work. Yeah, I have a slide about me so that you have an idea who's standing here. So I am founder of Jolin.io. That's kind of the key thing which I now like to spread. And yeah, next to that, I worked in data science like since it's feeling like always. From my start into university, and it's in total more than 10 years by now. And I've been working in consulting like more than 5 years. These are kind of two numbers. And because we're here also about tools, so these are my favorite tools. I use Binder a lot, and I'm very sad that it got sized down recently. Jupyter, I'm working on NixOS, and like it. It's bit tricky here and there, but it's really cool. I'm working a lot with Kubernetes these days and clouds, with web tools because everyone needs web tools, and actually also Julia. So I can also recommend to you joining tomorrow's JuliaCon. And if you want to reach out to me kind of between the chairs, philosophy of mind is one of my favorite. So, and if you also like this question, what does it need for a machine to become conscious? Just reach out. I love to discuss hours and hours about this topic. Okay, so what we're going to see today. Engineer? Yeah, this side, okay. So I'm going to introduce you Reactive Notebooks. So it was my work over the last months actually to get this working for Python. It's really the premier presentation. So we have just basics I want to go through, user inputs, which is kind of the key spirit, I think. That's the main spirit of Reactive Notebooks, that you can just replace whatever thing you want with the user input. And an awesome feature but it's less kind of, less generic self-updates. Then I have a couple of complete examples, and finally a little note on installing packages. I have a talk later on about the deployment part, which was already mentioned, which is more part of the Jolin business. There's a talk presenting Jolin.io in 2 hours. And I won't speak too much about the deployment part now, but if you have time, I also have kind of an attachment slide, and I can go to that too. But I think time is rushing. So I'm focusing on the Reactive Notebook itself and presenting its features. Okay. Yeah, it's really working there. Okay, let's go to Reactive Notebooks. So this is a kind of live demo. But because live demos were not allowed, it's all taken on video. So we have a lot of videos which we go through. And now I play the first. So welcome to the basics of this notebook. So what you see is that we have cells which are, like in Jupyter. We can execute them, and they have outputs. And now comes the first surprise. Bam! Wow, the output's on top. Okay, so many who use Jupyter, they prefer the output below, and they build a little helper to actually switch this. But this notebook just comes because of design decisions with the output on the top. As this initial configuration, so we can change this later on. But I keep it with the default now so that you get the spirit of this. So, and the key thing what we now do here is we make a little computation, and what this computation results in, you will see in a second. And the part which is kind of most important, so it always tells you kind of errors like normal in the cell, And the key part is now that it is reactive. So every time you change something, all the rest will be reevaluated. And the thing was already reactivity. So we imported square root from math, and it all automatically reevaluated the cell which depended on square root. So this was already reactivity. And we can also now change n again, and everything else will update. And which is kind of a key part also of the spirit, is that we don't have a distinction between markdown cells and code cells, but this is really all the same. And this gives you the feeling of, okay, everything is reactive. Also my output is reactive, my documentation, my self-documentation is reactive. And this little example is indeed computing pi, which is lovely. I took it from the documentation of the Julia version of this reactive notebook called Pluto, and adapted it to the Python world. And we go through this example in another slide. So what we can do also is that in every cell we can hide the input. This makes a lot of sense for documentation outputs, yeah, because you always don't want to see the markdown code. You only want to see the HTML part. And yeah, and this is kind of super simple, but we can also hide the input of all the other cells. So it's really a simplified version in a sense. Yeah, we only have one type of code cell. So, and after all my typing, this of course takes even longer if you record this. Yeah, so we finally will see some reactivity on the end. So we are now just interpolating stuff into our markdown, which works. I did a lot of work for this to make sure everything works. And we can now see it on the final part, so just changing stuff is going to reevaluate the rest. And yeah, so now you can kind of play with it back and forth. And I hope you get the spirit of the basics. So let me check if I forgot something. So we have automatic dependency tracking, which makes sure that only the cells are executed which actually need to be executed. So it's not always running everything, but it's really only running what really needs to be run. Yeah, okay. That have been the basics. So I was actually checking it's fine if we take some questions meanwhile as well. I just need to make sure I repeat the question. So please feel welcome to raise your voice or ask a question. This would be the first point where I think, okay, might be a good place to already ask a question. Someone, yeah, please. Thank you very much for this question. I was expecting it. So the question is whether the order output on the top, input on the bottom is actually enforced, and the answer is no, it's not. And I'm not sure, I think I have an example later on, but you can actually build a super tiny extension, which is just another piece of code which you execute in a cell, which interacts with the layout, and then it changes. And then if you delete the cell again, it switches back to the default version. So you can build such tiny extensions which also extend the layout. And yeah, I've done this already as an introductory example. Yeah, thank you for the question. I'll go on then. Yeah, this way. Okay, so next part. Wait, graphical user input 1. So now comes the key part to get you the feeling of how powerful this is. So let's hope the video's playing as well. It's a bit... No. Yeah, no, okay. There we go. So, okay, what we see right now is that the order of the cells actually doesn't matter. So you can move them around as you want. Dependency tracking is there to make sure everything is in the right order. And what we are now focusing on is that you can replace variables with user input. And we are now importing from Julia call the main package SJL. That's kind of the usual way to import Julia. And this is because the notebook called Pluto Notebook actually is originally from the Julia language. And hooking into it, the easiest way to get the UI elements is just to reuse the existing mechanism. But in principle, we can also support IPython widgets or the like. It's just, it just needs a bit of work. And as written out, if you like to help me, I really welcome help. So if you are curious about this and want IPython widgets to work here, reach out to me, and I can give you access to resources so that you can experiment. So what you see here is a little user input which is called a scrubbable, imported from the Pluto UI package. We're going to see it on the next slide. What other possibilities are there? You also have seen kind of auto completion, and all this works. And now we want to make our scrubbable kind of to replace our n. Hence, I was building with log space some integers, and we can input them into the scrubbable. And now we have kind of the same UI element, which reaches from 1 to, don't know, 10 to the power of 7. And now comes the key part. Now we can easily replace our definition with this input. And this kind of makes, so I'm uncommenting the n, because of type dependency tracking, there should always only be one definition of n apparently, otherwise it doesn't know where it comes from. And now we bind it. This is kind of the special magic function. This is, you just need to remember that special functionality bind will actually define the n and make it react on this UI input. And then we can also include it into our markdown. This was actually super, a bit more work than I was hoping for. So what I need to add is a special syntax. These, I'm not sure whether you ever seen this fragments. So like an HTML tag without an actually tag. And I like the syntax, it's very smooth. And with this, I have kind of a support of inline HTML, which is a little extension of standard Markdown, which does not support it. And you see that we now exchanged our n by this user input, and everything else works the same. This is the spirit. It's just the very same as before, just exchanging some manual input by some graphical user interface. And so in another summary, thanks to Reactivity, this just gets a dashboard. So this is like a cool thing about Reactive Notebooks. Okay, it was the second part. I think I get the next slide as well before again asking for some questions. So this is second slide, just an overview over all the interactivity which is already there, hooked in from the Julia side. And it should start. Now the video is also playing. So we have sliders, so which just update. We have, so the syntax is slightly different because this is not Julia. We have the scrubbable, which we just used, number field, and checkboxes. So there's really support for all the standard parts, text fields, and also, which is not here on this list, actually webcam input and all this. So you really just have the full HTML world to your feed. You can use whatever you want. And and to the best of my research, we can also make IPython widgets work. It just needs a little wrapper to confirm the event system, which is used by this Reactive notebook. File picker, which gives you an awesome idea. You can use this notebook just to upload an image on PDF and automatically trigger the analysis. And you can also download buttons. So you can really make this, like a website. So this is really plainly a notebook, but thanks to Reactivity, it's also a website if you want. And of course, videos and all this stuff. Okay. Is there some further question? Good point to get a question in. If not, I'm moving on to the next power feature. So this is kind of the key feature, I think. So this is really this which captures the spirit of React and Reactive Notebook, and it also comes well together with the point that there's only one type of cell. So it's not like you have kind of this distinction, but because of this reactivity, you really can merge your documentation, your layout kind of together with your code. That's one question.
You can make input changes, and can you hand this to someone else who can only change the sliders but not change the underlying code?
Thank you so much. So the question is, to repeat, whether there is a display mechanism to only interact with the slider, so the interaction part which is intended, and not change the code. And this is indeed kind of one of the ideas of which I realized in Joel and IO, where you have the deployment. yeah, and there's also kind of there are different kinds of deployments. So you can actually also deploy this as a plain file server, re-rendering, pre-rendering all the different combinations, yeah, and get out the Python core completely, yeah, so that you really only have a website, which then naturally is only interactable by the sliders. So this is one way, and I also built kind of another way because of the next feature, which self-updates. There you actually would need a running Python, and I also built the thing around there so that you still have this as a production view, yeah, so that you really see your website as a viewer and not as a developer. Thank you for the question. It's a really good question. Okay, quarter of an hour left, half time, and yeah, then let's look to the self-updates part. So this is a cool thing which delivers the real-time process. So we already saw this, actually now a stupid example. We saw this inputs, and I just have a little addition on top so that you get an idea. So this is not extending the basal problem, but nevertheless. So what we import now, some dates functionality from the Julia side, and we import another package of mine. This Joel and Pluto, which has a couple of helper function to get an easy kind of access to these features. And the first feature I want to show you is actually from the first question, the output part. So there's a special helper called output below in this package, and magically, bam, the output is below. And we can delete the cell and the output is again above. And because I myself also preferred below, I'm again putting it in and have the output below then. And yeah, so I admit this is also my preferred style. I use it all the time. So the same package gives a couple of other helpers, which also now give these self-updates features. And here I could in principle also support Python datetime. It's just as of now it's really kind of premiere fresh. I'm still using the Julia dates format, but as you see, it's super simple to support kind of the Julia dates format. And you see also Julia has awesome algebra support, or what's this called? You can work with dates in a very intuitive way. We take kind of a seal of the current date, rounded to the next 2 seconds up. And what you see now, I guess the video is already over. I hope you saw it. It was self-updating. Yeah, it's already over. I missed it. I hope you haven't missed it. Yeah, I have another example which gives this a bit more a bigger feature. So this is the very same idea now, yeah? So we exchanged the manual input before with the user interface input, and now we exchange the manual input with the server-side trigger, so to say, yeah? So we have client-side triggers and we have server-side triggers. And this just can go together. And yeah, and I go on to the next example to illustrate this in a bit more ways. I have a little break for myself. So I like XKCD arts, and I actually like this especially. Yeah, I hope you can appreciate as well. So it's really good to have the right tools, yeah? And paper is an awesome tool. Yeah. So of course you can't do this with a reactive notebook, but it's still a great analogy. Okay. So stream example. This is a full little tiny demo for giving the self updates. And this comes kind of with the examples from cloud.jolin.io. If you go there and log in with GitHub and create an empty environment, you get these example notebooks, which give you kind of an introduction to the features. And you see, Julia, Python, and R are there supported, and today we are focusing on R. So let's start this video. Yeah, works. Okay, so we're going to the streams example, and it's already started and running. And we have some summary on the top. So we actually have a table of contents feature also, which just there, a Pluto UI feature. And I built some little UI inputs which can change the shift. You see immediately what shift means in this context. So we're generating some time series data, like a random walk, also called, and we can just change this. And this is a kind of as a summary just. And we have some code. We import our tools. Um, import queue threading for the self-update support as a little demo. With a dequeue, we create now kind of the part we create updates. So initializing the queue and having a little thread, which always puts elements into the queue, just normal, a threaded queue we use in Python, and then we can fetch the updates. And now there's a special function Pluto.repeat queue get. So this I supported because it's queue as the interface, and then things update automatically every time something new comes. We have the UI part, we we can build them separately, but we can also combine them into some markdown table, which we've been using at the top. We have also a plot, which is now just kind of just matplotlib, and that was it. So it was a bit quick, but I hope the preparation before was okay to get you an idea. So this is just kind of a super tiny demo, So in real life, you would. What I now want to show you is that here above we have just a summary. We repeat um, the the input element and we repeat the figure, and just on top. So bam, we have a summary at the top, and it's really very straightforward, very simple. And in general, I like this approach, like having a summary on top, some other sections, and also how it's implemented section, implementation detail section. So of course you could build dashboard which hides all these other things. You actually don't need to press hide on everything. You can also have a view which only focuses on certain cells. This is also possible. But I appreciate actually having this within the result. To have something which shares also the implementation detail. I appreciate this knowledge sharing part of it. So you give a summary at the top with all the key information, for controllers, for managers, whoever. But then you still leave the implementation details below, And if someone is interested, he can kind of look into it. And this is really, an easygoing open spirit with one, notebook which summarizes it all. And I really like this way. And what's also cool about this, maybe you already realized this is mobile friendly. So this is linear. It's intended kind of also for on mobile, and you can actually go to cloud.jolin.io also of your mobile device. Log in there and use it. It's in a sense one of the first really working coding environments on mobile. But of course you don't need it for development necessarily. You can also just take it for viewing. And I appreciate also this. You're used to 2D dashboards. But I think this is worth to rethinking. Worth to rethink it. So that a more linear style of thing just better fits our world today, especially in a mobile sense. You can still get wide dashboards. You can also stack things next to each other. That's also possible. You can also still use this with the reactivity. But I appreciate this linear style. It's just simpler, and makes a lot of sense. This updates I wanted to add. You can read, of course, of any event system, queue system. So in principle, also Kafka or Red Panda, Kinesis. So this doesn't have to be a pseudo-random number generator, but can be a real system where you get updates from, and just by this you have a stream processing. You write it back to another queue. You write it back to an event system. I'm mainly on AWS, so yeah, simple queue service is super easily integrated. Just bam, it's there. And on Jolin IO, there's also kind of this, you need to authorize your notebook. This key thing is also taken care of if you like to use this in your company. These things are also there. Okay, another 5 minutes, but because this is a key feature, are there questions to this self-update? Please.
There's one. I was thinking, if there's a lot of dependency between those cells,
Yeah.
and one of them gets an update. In your example, you import an additional module. All dependent cells get updated. But what if that updates take that amount of time on CPU just hangs? Can you interrupt or even disable self-update?
Awesome question. So the question is how to work with cells which run for a significant amount of time and thereby will block your workflow when always run on reactive triggers. And yes, you can do both. So you have the possibility to have an interrupt. You see kind of if it's running, a clock increases or it's running for this amount of time, and there you can directly kind of hit kill it. Yeah, and the second part is even more powerful. Yeah, you can disable it. And this took me actually quite a while. The self updates have different flavors, and the naive way or the first way which I've stumbled upon was actually not working well with this disabling. So in principle, you can actually a cell has a three dots where you have a little menu, and you can disable the cell, and it will disable all the dependencies. And I actually made sure that also the self updates are working with it because there's some server side logic going on. So if you change something on the client UI part, it doesn't necessarily work well with the server side part. So it actually, in the first implementation, it still went on and you had this problem. But I made sure that also the self updates, if you disable the cell, it's running one last time and then it stops. And so you have real flexible way also of switching between the real-time process way or kind of stopping it and experimenting with further changing a bit here and there. So this is there and super flexible. Thank you for the question. Okay, so then let's go on. We have a couple of minutes left. Just want to show you, just for the completeness, of course you can build dashboards. And this is just a tiny CO2 plot. Doesn't fit on this screen here. I was cutting it. But of course there's also an x-axis label, yeah. I always put an x-axis label on my plots. And this just, a Plotly example, yeah. So matplotlib put through the Plotly converter already works out of the box. And you have a nice interactive HTML plot as well. And what we see is that the Netherlands have been doing better than Germany for quite a while. But it's now on the same scale. And of course all on a bad scale, So key thing I wrote here on the left, Plotly tools, matplotlib to Plotly. This is just what's used here, and then you have also the interactive HTML plot, which are always awesome for dashboardy things. And we combine kind of now, of course, the reactive notebook part, having this input interfaces with a Plotly interaction. So this is easygoing and super intuitive. Okay. So installing packages. 1 minute left, but we have 5 more minutes for further questions. So I just want to show you kind of the last key feature. You remember our outline. Package installation is handled automatically. So you just start up your notebook and you import and things are imported for you, like installed. And this is done by Condor in the background. And thanks to Condor, this actually is also really smooth because it has pre-packaged binaries. And we can hide the logs. Have you seen this? It's also there was also the disabling feature on the same menu. And we can do further stuff with NumPy. And yeah, this is kind of also a spirit of this reactivity from the Julia side, this automatic package handling. And yep, okay. So future plan. I want to support. Okay, whoa. We have 5 minutes for questions, and because we took questions, I can kind of made it a bit flexible. So I want to support PySpark clusters because the setup on cloud.jolin.io is Kubernetes based and should be able to just integrate a cluster which you control from this reactive notebook. A Ray cluster as well, and I also would like to see IPython widget support. And if anyone would like to help me on this, I'm more than happy to, yeah, to get you on and get your help. Okay, so summary. Huh? Okay, so let's make it quick. So we saw the Reactive Notebook. You can use it for experiment, just experimentation. It's this reactivity gives you a cool feel of just experimenting. Everything else is updated. You have this dashboard by just replacing manual inputs with UI elements. You can transform events with the self-update, have kind of a stream, a real-time process, and hopefully in the future you can also transform big data by just spawning a whole cluster from your little reactive notebook, interact with the cluster and destroy the cluster again, and just kind of, all from one script. And that's the plan. And on cloud.jolin.io, I haven't spoken too much about it. This is kind of the place where you can test this right now. It's kind of a hosted reactive notebook service. You can collaborate, and you have dev, test, prod automation more later on in the talk about Jolin.io. Yeah, I hope you got this joke. If not, it's not so important. The time is tiny. Okay, so we have a couple of more minutes for further questions. Thank you very much for being my guest today. Please.
So the order of cells doesn't really matter because the dependencies are inferred. What if I define n is 1 and n is 2 in different cells?
Yeah, so the question is, what is if one variable is defined multiple times? And then an error will be thrown, actually. So it will tell you, stupid, you should define n only once. And then,
Thanks, guys.
yeah. And yeah, so sometimes you actually want this. And if you want to kind of mutate something, update something, so what you do is to build a container, which is not recognized as a normal definition. If you just make a equals 2, that's interpreted as a definition. But if you have a equals list of one element, and you update this one element, then it won't complain. So, and this was actually also used. We have this plot, with this random walk, and this was a DQ, I don't know how to pronounce it. And this is just a list, so we append something, and it updates itself. And we had a cell which initializes this, but this is not triggered again. The dependency tracking will skip this because it's not depending on the update. The update only pushes it into the collection, and because it's of a fixed maximum size, it's awesome for these real-time processes because it doesn't explode in memory. So these kind of things you can do.
Since we run a little bit long, we have time for one more quick question.
First, but you're happy to come to me and ask further questions after the talk.
So does this already work with WebAssembly? So that it would run in your browser and then type it out?
So the question is whether it already runs with WebAssembly. I think not. So the idea is also kind of to have it more as a server side thing to really have these processes and to access data which should be secured somehow. But it would be awesome also to kind of to give whatever could be given to the client side, in form of WebAssembly. Background is that the core implementation of this notebook is in Julia, and Julia uses a lot of just-in-time compilation, and WebAssembly is not yet there with code generation. And while this is in process, as I know, it's not that that easily possible to transfer this to WebAssembly yet because of this dependency on code generation. There are efforts, but I guess it takes a bit more time. So Python World is easier to get to code assembly because you don't have this just-in-time compilation. But the Julia side depends heavily on JIT compilation, and there it's a bit more difficult. So I think answer is not, and I guess not in 2 years. Yeah, thank you.
Okay, thanks everyone also for your questions. Thank you very much for a nice talk. You also have
Thank
a
you,
talk,
Matt.
I think, in the startup track later in this morning,
Yeah.
right? So if you want to join that, you can go there as well. And then we'll close with another big round of applause.
Thank you so much.